Welcome to The Explainer. Today, we're going to break down a core concept in AI that you use every single day, probably without even realizing it. It's the secret sauce that lets machines make sense of our world.
Right? Ever wonder how your phone does that, or how your email knows what's junk and what's important? It all comes down to one really powerful idea: teaching machines how to find order in all the chaos around us.
And that idea is called pattern recognition. At its heart, it's all about training a machine to spot meaningful patterns in raw data, whether that's in images, sound, or text. We're basically trying to give computers an ability that we humans are just naturally good at.
Okay, so here's what we're going to cover. We'll start with the basics, how we humans do it. Then we'll look at the machine's blueprint. We'll explore the two big ways they learn, find out where you're seeing this stuff every day, peek under the hood, and finally, look at the good and the bad.
Before we dive into all the tech, let's talk about the original pattern recognizer, which is, of course, the human brain.
I mean, think about it. We do this stuff effortlessly. You can spot a friend in a huge crowd, read someone's messy handwriting, and you definitely know a cat when you see one. The whole goal of AI pattern recognition is to copy that incredible human skill using algorithms.
So how in the world do you teach a machine to see patterns? Well, it's not magic, not at all. It's actually a pretty structured process, what the experts call a pipeline.
And this really shows the whole journey, from messy data to a clean decision. First, you collect the data. Then, you got to clean it up. That's pre-processing. Now, step 3 is the really clever part: feature extraction. This is where the machine learns what's important. Like for a face, it might be the distance between the eyes. Then an algorithm classifies it, and finally, a little post-processing refines the answer.
Now, what's really interesting is that these systems can learn in a couple of different ways, and it all depends on the kind of data you give them to play with.
So think of it like this. Supervised learning is like studying for a test when you already have the answer key. You show the machine thousands of emails already labeled spam or not spam, and it learns the patterns. Unsupervised learning? That's like being thrown into a library and told to organize all the books into categories yourself, without any hints. You have to find the patterns all on your own.
You might be thinking this is all super high-tech, abstract stuff. But I promise you, you've used pattern recognition a bunch of times already today. It's literally all around us.
When you ask Alexa for the weather, it's recognizing the specific patterns in your voice to understand what you're saying.
And that spam filter in your inbox? It's constantly looking for text patterns to figure out what's legit and what's just junk mail.
Unlocking your phone is the perfect example. It's not just looking at a photo of you. It's matching the unique pattern of your facial features to a template it has stored.
And in healthcare, wow, this is a real game changer. It's helping doctors spot subtle patterns in medical scans, patterns that could be the earliest signs of a disease like cancer. It's just an incredible tool for them.
All right, let's pop the hood for a second. You don't need to be a math whiz to get this, but it's pretty cool to see the kind of logic these machines are using to make decisions.
Okay, so a formula like this one, Bayes' rule, is a cornerstone of this whole field. But forget the symbols for a minute. All it's really doing is helping the machine update what it thinks based on new evidence. It's basically asking, okay, given these specific features I'm seeing, what's the probability this is a cat versus a dog? It's just a formal way to weigh the evidence.
Now, as with any powerful technology, pattern recognition comes with some incredible upsides, but also some pretty big challenges we really need to be aware of. So on one hand, it's amazing. It automates complex tasks, can be way more accurate than a human, and it scales like crazy. But it needs enormous amounts of clean data, it can be super expensive to run, and this is a big one. If the data you train it on is biased, the AI will be biased too. Some of these models can also become a black box, where they give us an answer, but we can't fully understand how they got there.
And that brings us to one last thought. The future here isn't just about what machines are capable of seeing, but about what we, the people building them, choose to show them. Because in the end, they only learn the patterns we give them. Thanks for joining this explainer.